Okay, I'm Laura Block, and I'm related to Steve. We had MP3. A baby. Okay, so this is our example problem, and you can just kind of work on it on the back of one of your sheets of paper. Mrs. Hauser had 4 pizzas. Each pizza had 8 slices. If Mrs. Hauser ate 50% of the pizza slices, how many slices were left? So go ahead and start working on it. And when you kind of got it, then talk to your shoulder partner and see how they figured it out. This is a 5th grade problem. Everyone think they've got it? You guys got it? Okay. Okay, so here, I'll go back to the problem here in a minute, but ours was construct viable arguments and critique the reasoning of others. And then a student who can construct a viable argument and critique the reasoning of others is a student who is mathematically proficient. They can look at data and make logical conclusions about it. They understand arguments and can present arguments of their own. They can listen to and understand arguments, but also figure out if they make sense or not. And they can construct arguments using concrete references such as object drawing, diagrams, and actions. So on the example, we had the picture, so you can actually have a drawing of your example. So for the problem, there's lots of different ways for students to work on it. Some students will figure out how many slices there are total, and then they'll take 50% of that. How many people did it that way? Okay. And then another way is to actually cut each individual pizza in half and then add up the 4 pizzas, what's left over. So 8 divided by 2 is 4, and then add up all your 4s to get 16. Did anyone do it that way? Yeah, that's the way I would have done it. There's other ways, of course. So we're going to have you talk with your partner and present your argument to how you solve the problem. And then allow your partner to critique your argument and give suggestions as to how you could have better shown how you solved the problem. So you want to talk with your partner about how you could. Okay. Did anyone have a different way of doing it that wasn't listed? Okay.
I just eliminated 2 choices. I don't know if you said this because I'm kind of deaf right now.
You're fine.
Yeah. Anyway, I just looked at the pizzas, like you said, 8 slices of pizza, and there's 36, 32 in total.
Yeah.
I'm so tired.
Yeah,
There's 32 in total. So I just divided the 4 pizzas in half. That's all I did.
Yeah. So yeah, you're using percent and division and adding all at the same time. So there's lots of different ways to do it.
Okay. Students who know how to construct arguments and critique the reasoning of others, the other part, do these actions. They use math correctly, or the correct math vocabulary, and they can write their understanding of math terms in their own words. They can describe it and be able to tell other people and kind of teach other people how to do it. They can make their own conjectures and explore them. and figure out if they're true or false, like we said. They communicate and justify their solutions, so not only can they try and write down their own math vocabulary in their own words, they explain it to other people and justify this is why you do what you do. They can compare two arguments and figure out which one works best, or if they both work pretty much about the same. They can question where data comes from, so if they're not sure, like if the numbers are correct, they can go back and figure out why people got some of the numbers that they got. Like with the pizzas, they can figure out, well, there's 8 slices per 4 pizzas, so that's 32, so there's the numbers that you're looking for. Obviously, they question the reasoning of others, because if they're critiquing their arguments, then they've got to figure out, okay, is this really right? Are you telling me what's true and it's not? They explain the flaws in the arguments. They use pictures and tools, like our pizza pictures. And they can listen and read arguments of others, which is pretty much obvious. The way to adapt this information to younger students, you just adjust the level of difficulty of the math problem. Example, the 5 plus 7, you'd have to convince the students to carry the 1 when you're adding them together. You know, like, I don't have a board, but you put your 5 plus 7, carry the 1 over. You'd have to show them with the number blocks or with your hands that you run out of fingers. If you have 5 plus 7, you're running out of fingers on your hands, so you'd have to add a whole other 10 block to make the problem, or the answer 12. You could have the students make up a problem for them to solve, and have other students try and figure out the problems, kind of out of that as an activity. And then you want to do your first two?
Okay. For the SIOP model, students can construct viable arguments and critique the reasoning of others. They can do this by comprehending the information that's in front of them, so basically just reading the problem and knowing what it's asking. They can strategize to find out if the argument is valid and come up with their own argument. And the students, they have to learn how to interact with other kids to know how to comprehend the information that they're telling them. They have to be able to explain their reasoning, so they have to be able to work with others. They have to be able to practice the arguments and apply them in the problems in order to successfully critique and construct arguments. And finally, the students that can accomplish this mathematical practice must be able to review and assess the arguments presented in front of them to actually know what's going on in the problem. And those were our works cited. We found the SIOP components that we discussed at that first website, and then the definition for our mathematical practice in the second one. And what was this one again? No, that was the students who are mathematically proficient do these actions, like that big list that we had. So that's it.
Okay, comments, questions about MP3? Let's go.
We don't grade ourselves, do we?
No questions?
Just kidding.